Okay, so let's take a look at the Unit 1 homework problem number 4. And specifically, we're going to look at part 3, or part C. So in parts A and B, you basically convert, that each train travels 221 miles, and you convert that to their speed in meters per second. So here's the situation. We have a train leaving Boston, okay, traveling to New York City, okay, which is 221 miles away, or if we convert that to kilometers, that's going to be 356 kilometers. So we have one train that is traveling in that direction, and we know that train, we'll call it train A. Okay, and we know the speed of that train. We solved for that in part A of the problem. So speed of train A is going to equal, 27 meters per second is what you find. So 27.0 meters per second. Okay, and then we also have train B that departs at the same time from New York City. Okay, so train B is departing from New York City. And train B is traveling in the opposite direction at 24.0 meters per second. And in part C, what you're asked to do is figure out where they are going to pass each other. So these tracks are parallel. They're not going to crash, but the train tracks are parallel. So we're trying to figure out, okay, where do they pass each other? Okay, so intuition tells us that because the speed of train A is a little bit greater, that it's probably going to be a little bit over halfway to New York. So they're gonna cross paths somewhere here, okay? And this happens at time t. Okay, let's call that time t. At t equals 0, they're both departing. So at t equals 0, train B is here, and at t equals 0, train A is here. So at t equals 0. Okay, we need to do one more thing. We need to set up. I set up 356 kilometers, but I was kind of not specific here. This is my 0 kilometers. So that means that my reference frame, the positive direction is to the right here, or towards New York. Okay, so that's kind of the setup of the problem, visually what we're trying to figure out. So let's figure out what we know. Well, we know that train A is going to travel at 27 meters per second, and it's going to cover some distance in time t. So let's call this distance A. Okay, so the amount of distance that train A travels, and train B is going to travel some distance B. Okay, yes, the problem asks us to find the displacement, but right now we know the speeds from part A and B, so we're going to deal with distance, and then we can think about what we would report as the displacement after we figure out the distances. Okay, so one of the keys to this problem is realizing that the distance train A travels plus the distance train B travels has to equal 356 kilometers. Okay, because we're figuring out where they meet. Okay. So that's one equation with two unknowns. So we can't do much with that yet. Okay, but we do know a little bit more information. We know the speed of A. We know 27.0 is going to equal the distance train A travels divided by the amount of time. Okay, and we know that, so we know that's for train A. And we know for train B, we know that 24.0, its speed is going to equal the distance it travels in that time t. Okay, so we've added another variable t, but now we have 3 equations and 3 unknowns. Okay, so we should be able to use our algebra skills. If we have 3 equations and 3 unknowns, dA, dB, and t, we should be able to use our algebra skills to solve for each of those variables. Specifically, we want to know the distances, so it might be useful, since our reference frame is 0 right here, it might be useful just to, let's start out by seeing if we can figure out what dA is. So what I'm going to do is I'm going to combine these 2 equations, Okay, so I know if I rearrange the first equation, I know that, and I'm going to rearrange actually for t. So let's rearrange this for t. Okay, so t is going to equal, well, I multiply both sides by t, and then I divide by 27. I get t equals dA divided by 27. Okay, and I also get, if I solve for t, let me change my color here for a second. If I solve for t here, I get t equals dB divided by 24. Okay, so this actually helps me out because I can now set these equal to each other. This is the same time, right? That's one of my requirements here is I'm trying to find where they pass each other. So that amount of time, if they start at the same time that we say is time 0, they're going to pass at time t, where dA plus dB equals 356. Okay, so this occurs at time t, right? This equation that we set up. So I say dA divided by 27 equals dB divided by 24. And let's multiply both sides by 24. So we get dB equals 24 times dA divided by 27. Okay, so what we actually have here, if I plug this value in for dB right here, I actually only have one unknown now in that equation. Okay, so let's do that. So I'm taking this equation and I'm plugging in 24 divided by 24 dA divided by 27 for dB. Okay, so I got dA plus 24 dA divided by 27 equals 356. Okay, well, if I factor out a dA, I'm left with 1 plus 24 divided by 27 equals 356. So I get that dA equals 356 divided by 1 plus 24 divided by 27. Okay, and I plug that into my calculator, and I get that dA is a distance of 188 kilometers. Okay, so the displacement, so here's where, so we know, let's go back to our picture. So we know this is 188 kilometers now. So we solve for that. So now what we're supposed to report is actually displacement. Okay, so we need to add like a positive or negative sign depending on the displacement of the train. So dA has gone, or dA, train A has a displacement of positive 188 kilometers. That's its displacement or its change in position. Okay, and train B therefore has a displacement of negative 168 kilometers. Okay, because remember in our reference frame, dA starts at 356 and ends at 188. So when we're finding a displacement, a delta x, we take our position final minus our position initial, and we end up with a negative number in this case because we take 188 minus 356, okay, to get the 168. Okay, so the trick for this one is really realizing that the two distances they travel is going to add up to 356 when they pass each other, and this occurs at the same time t. And that allows us to set up, knowing the speeds, it allows us to set up an equation, 3 equations, and with 3 unknowns, so dA, dB, and t. And then we're able to use our algebra skills to solve for the distance train A has traveled to find this spot at time t. And then we can turn that into, using our knowledge of displacement and what that means, turn it into the displacements of each of the 2 trains in that time. Okay, so I hope that was helpful. And please let me know if you have questions on anything else.